So, a couple technical difficulties with the Google Meet, and the computer froze up, lost my screen recording. So, if you were hoping to see this and see the original, I'm afraid not. I'm going to just go through what we went through during that Google Meet, and we're going to talk about Unit 5, Topic 1. So, in Unit 5, there is a lot more knowledge-based stuff in this one than in the previous chapter. So, what I mean by knowledge-based is kind of recalling facts, recalling the names of different things, less calculations, less deep concepts to understand per se, and just kind of learning some of the facts. So if you're good at memorizing definitions and stuff like that, this should be a breeze for you, especially if it's open book. So, World of Water, why is it entitled that? Well, because the Earth is full of water. In fact, 71% of the Earth's total surface is covered in water. From space, we're blue. We're referred to as the blue planet because what you see from space is a planet that is covered in water. And water, scientists believe, is what makes all life possible. So, if there is life on other planets, scientists believe that means that water must be present on those other planets. So let's talk about the distribution of the Earth's water. So again, the Earth is 71% water as far as the Earth's surface goes. Of that water, 97% of that water is salt or saline water, so meaning oceans, seas. As we know, those oceans are very vast, they're huge. So they comprise the vast majority of our water. So that makes 3% of the water on Earth fresh water. But of that fresh water, only about 0.02% of that fresh water, or of the total amount of water, is found in rivers, lakes, ponds, or is water that is surface water, surface fresh water, I should say. So where is the rest of that water? Where is the rest of the fresh water? If we look at this graphic right here, we can see that of that fresh water, 69% of that fresh water is in the form of ice caps and glaciers. So if you go to the Antarctica or the North Pole or Greenland, it's covered in ice. That ice is fresh water. However, it is not usable because it is frozen. So it isn't much good to us as humans, but we do want to keep it frozen so that it doesn't melt and flood everybody out of their homes and make us all head for the top of the mountains because now the Earth is overflowing with water. So 69% is glaciers. 30%, so that the other third of that water is groundwater. So like when you dig down and get water out of a well type of thing, you're getting groundwater. So usable, but you have to be able to acquire it through something like a well. And then what about the rest here? We have surface or other fresh water. That's 1.2%. So a very small percentage is actually the fresh water that you might be familiar with. All right, let's move on here. This is a graphic from your textbook that shows the distribution of the water. The oceans and seas, again, 97%. Groundwater represents this dark sliver here. Rivers, lakes, ponds, glaciers and ice sheets right here. And this little teeny tiny sliver right here represents rivers, lakes, and ponds, which is equal to 0.02% of all of the water on Earth, which happens to be the most useful water. It's also in the smallest quantity. There's very little. All right, this graphic right here represents the amount of renewable fresh water or surface fresh water on Earth. So we have Brazil accounts for 18% of the fresh water on Earth, Canada 9%, China 9%, United States 8%, so just slightly behind China and Canada. And then all other countries combined, all 200 plus, or not 200 plus, but around 200 other countries in the world combined for only 56% of the fresh water. Now, why do you think there's this uneven distribution, and why do these four have so much more fresh water than the other places? There's a couple of reasons. First of all, if you look at this on a map, Brazil, Canada, China, and the United States, you're going to notice that they are all very large countries. Very, very vast, very big area. That's one. Think about Brazil, though. Well, it's got the largest rainforest in the world. The rainforest is very humid, full of wetlands. Also, the Amazon River flows out of the Amazon. The largest river in the entire world is there in Brazil. So Brazil is a very, very abundant nation as far as water goes. Canada, United States, if you think about that, well, we have the Great Lakes. You ever heard of those? You know, Lake Superior, Lake Michigan, Lake Huron, and so on and so forth. Those are very large bodies of water, comparable to a sea or an ocean. If you go along the border of one of those Great Lakes, you're not going to see to the other side. No way you are. They're very, very large bodies of water. And then all other countries, China has obviously a large supply. It's also a very large country. But just remember that graphic and remember the percentages of those different countries. All right, let's talk about water quality and quantity. Quantity refers to the amount. That is a concern, obviously, since only 0.02% of the world's supply of water is fresh water. But water quality is also something that we need to think about. Now, remember this definition. Water quality are characteristics of a water resource that make it suitable or unsuitable for various uses. So suitable is kind of the key word here. Obviously, we want clean, fresh water free of contaminants that is going to make it suitable for our needs. All right. Not to rehash something that I'm sure you've learned before, but we have the water cycle that we need to talk about. There's a few key things that you need to remember with regards to the water cycle. First of all, the thing that powers the water cycle is the sun, because without the sun, there is no evaporation. Without the sun and no evaporation, there is no condensation and thus precipitation. Without precipitation, well, then we can't water all of the plants, forests, rainforests, everything, because there's no precipitation. And this cycle cannot repeat without the sun. So the sun is very much that motor that drives the water cycle. If you don't remember what the changes of state are, you need to review that. So, for example, solid to liquid, when we're referring to water, if an ice cube melts, it is changing from a solid to a liquid. Melting, also referred to as sublimation, is that change from solid to liquid. What about liquid to gas? So, for example, this body of water right here is liquid. It's in its liquid form. The sun evaporates that water, and that changes it from a liquid into a gas, and we call that condensation. Sorry, did I just say that backward? I think I did. So, let me just say this one more time because I'm not sure what I just said. We have a body of water, sun acts on it, and it evaporates it, and it changes it in from a liquid to a gas. When that that water vapor, which is in a gaseous state, condenses or goes through the change of state from a gas to a liquid, we call that condensation. Condensation leads to precipitation or rain, and that's how the cycle goes. Then when the water falls, it runs off and it rejoins those big bodies of water, and the cycle continues to repeat. The water cycle helps to purify our water and provide clean water. However, it doesn't mean that we don't have to take care of our water. Let me put it to you this way. Say that this body of water is full of contaminants such as mercury or 2,4-D or other chemicals. When it evaporates, the mercury and the other chemicals do not evaporate with that water. Only water will evaporate with it. Okay? The mercury stays behind. So even though this process continues, if there's still mercury in that body of water, it's not going anywhere no matter how many times this cycle goes. It's going to bioaccumulate in the fish and so on and so forth and cause damage. So just because we have this cycle that does purify our water, the rainwater coming down, so long as it's falling through clean air, is going to be pure water. However, we still have to be very careful how we treat our water, which leads us to the next point, water in humans. One of the key things here that I need you to understand is that water does not stay constant in your body. If it did stay constant, you would not need to drink water. Now, obviously, we know that if we go without water for 2 or 3 days, our body shuts down and it dies. So, obviously, water does not stay constant. We lose water in a variety of different ways, one of those being perspiration or sweating, exhalation or breathing, and elimination. So when you do your business number 1 or number 2, you are eliminating water from your body. So in order to replace that water that is constantly being lost, you must drink water. You're going to lose excessive amounts of water, especially when you are exercising. If you are playing in a basketball game, you are going to sweat out a fair, significant amount of water. Any coach will tell you to make sure you're keeping hydrated and so on and so forth, because they understand that you are losing water. Your body, when you get thirsty, it's telling you that you are in need of water. Your cells need water. So, where do you think you lose more water when you're playing a sport? Do you think you lose more through perspiration or exhalation, through breathing? The answer would be perspiration. Although when you increase the amount that you breathe, you are going to lose more through breathing, but you will lose far more through sweat than you will through the breath that you are breathing out. So when you breathe out, you can feel that it is kind of moist because there is water vapor in your breath. So you are losing some when you breathe, but not to the same extent as if you are sweating. All right. Water management, this is our last slide. What does this mean? Well, water management means that we are balancing the water needs of people, industries, wildlife, and the environment with the ability of freshwater systems to remain plentiful and clean. Now, plentiful and clean, that kind of brings us back to the discussion regarding quantity and quality. Plentiful meaning the amount, and cleanliness being the quality of that water. Now, notice that someone who might enter into a career in water management, they can't just think about the water needs of people. They have to think about the water needs of everything and everyone, including wildlife, environment, industry. If you focused simply on the water for people, you're eventually going to run out of clean water. If you focused on the water needs of wildlife, well, that doesn't get people good, clean drinking water. But really, these are all intertwined. So, for example, if I am a farmer and I need to irrigate in order to produce good crops, well, there are going to be water management people in place to make sure that there is an irrigation set up for those farmers to get the water to their environment or to their fields so that they can grow those. Do you think that that is connected to people? Absolutely, because we need to eat those crops. So water management is really making sure it's a really comprehensive thing involving a lot of different thoughts and ideas as to who is in need of this water and how can we ensure that it is plentiful and clean. So how would your quality of life alter, or how would it be affected if Alberta's freshwater supply were contaminated? The reality is that every aspect of your life would be changed, and not for the better, if your water supply were contaminated. Wildlife would begin to die. The environment would be affected. Sure, maybe we could bring in bottled water for people to drink, but everything around you is going to be really struggling. So every aspect of your life would be affected. There is a reason why people live in areas where water is abundant and accessible. People do not live in the middle of the Sahara Desert if they don't have accessibility to water. Water is key to life. People do not live in the middle of the frozen tundra of Russia where there is no water, or the Antarctic, where you don't have access to usable or suitable water. So, water management is important, and that really concludes topic 1 of Unit 5. If you have any questions, feel free to contact me. You can do so through Google Classroom, or you can send me a direct message to my email. And I wish you the best of luck. The quiz is a little bit longer than some of the last few that we've had, but it is very knowledge-based. Again, it's open book. Lots of just key concepts, and not key concept, but just kind of terms. And you're going to see that there's going to be more terms in the next topic as well, but they're all accessible to you through your book and through the resources that I will provide to you. All right, that concludes everything.